share with you some ideas and already algorithms done in the artificial intelligence world, with the focus that PIX4D has to reduce time of the people working directly on the computer. We are creating this automation and automated tools, starting from this new type of algorithms called artificial intelligence, and specifically with machine learning algorithms. Our blood and our DNA, basically, it's data. So thanks to the data that we produce, we can make better decisions. So, but no better decisions can be done without any analytics. So good analytics are also at the base. So that's why artificial intelligence matters. The automation is a key to extract value from this data, from a lot of data, good amount of data, and a big amount of data. So imagine multiple projects done at the same time, at the same site, are producing a lot of data. So at a scale, PIX4D has this integrated approach using artificial intelligence with many diverse views of the data. So 3D, images, DSM, and DTM. So this is just try to see, okay, what is artificial intelligence and machine learning? So basically we start creating a model on PIX4D. Thanks to the PIX4D, we create the design and train the model, the algorithms. Then we test and we deploy, and we need user feedback also to understand where it falls. So an example. So you know what is this? It's a target that is used for ground control points and markers. The goal that we had some time ago was to substantially reduce the marking time of getting a ground control point. So here, however, it's very, very hard to see and spot the ground control points. Possibly an expert eye can understand. But basically, here we are. So this is the number 2 here. And this is the other one, number 3. So what did we do here? Basically, we analyzed both the 3D model, the orthomosaic, and also each image to spot these shapes of pixels and these texture neighbors differences in order to automatically detect and mark the center of the target. Thanks also to the geo information of the CSV file coming from the targets, for example. Another case study, so these are case studies that are algorithms that are already working in our tools. The automatic extraction of measurements from the antennas and defining the position and the estimation of the position of the antennas. So define the geometry and the location. These, for our clients in the telecommunication industry, are basically enabling, these algorithms are enabling the proper asset management with a fully automated pipeline that otherwise is tedious and long to be done manually. I don't spend much on these. And this is actually the real case. So how we detect them. This is a 3D model coming from PIX4D scan and PIX4D inspect. And that's the antenna with here all the information, down tilt, azimuth, orientation, angles, dimensions, and the coordinates, so the geolocation. So it's fully automated. Okay, now what are we working on? Very often when you do inspections, in order to avoid that these points will somehow increase their size and destroy the beams. So basically, in order to maintain and properly create an operational maintenance workflow. And this is actually what we started to do. So we analyze the entire project, both in 2D and 3D, and we define where, so you can go back and forth, where the rust is. So then it's up to the user to understand where to go and see, okay, here it's a lot rusty, okay, let's go and check it. And then the specific algorithms that PIX4D server will see. This is the semi-automated extraction of information in PIX4D server creating. First, starting from the 3D model, checking the images, click. Click. Okay, perfect. So the terrain generation, classification of terrain and non-terrain. So the green is the terrain, the blue is buildings, trees, cars, everything that is not terrain. So we classify these two classes. Then there is also this possibility, checking the manholes. Here. Same type of shape, more or less similar colors, and then we identify them automatically, fully automatically, within the 3D model and the mosaic. Same for the drainage. Yes. Go. See different spots. And these are the drainage systems. So imagine how long and tedious is to spot manually for an operator or a user to spot to spot manually all these manholes and drainage systems. It can take really long time, and very often you lose some of them because you don't see. So this is a fully automated workflow. Okay. And here it's the example of the automatic road mapping, just with lines, with just two clicks on a line. It can be the continuous line or even the different segmented lines. The vectorization, this is a vectorized file. It's fully automated and can go for kilometers. Then it's a shape file, a KMZ, DWG, DXF files that can be exported. Similarly, go on the other one. Here is the classification, as we saw before, the classification of the road. So road classification. That's basically selecting a palette of colors appearing in the same image, in different images, and then basically that is the road. So we identify the road and we extract it automatically. And can be classified in the group files of roads, purely. Okay, go on the other one. And this is the last board, let's say, related to artificial intelligence. Automatic extraction of stockpiles volume calculations. With one simple click, we defined the kind of a shape in 3D and 2D, the shape of a stockpile, of a volume, and with one click, the user can with one click in the middle, or wherever it could be the cone, then we define the perimeter of the baseline that creates the base of the cone for the stockpile. And then the volume calculation is computed automatically. So here is basically where we are applying artificial intelligence, the new algorithms for machine learning that we have seen. A lot will come also in PIX4D survey Inspect Cloud, and specifically for PIX4D Catch, with what we have seen today with the VDoc. We have specific workflows that are starting to come for indoor mapping, where we will automatically check and tag points, specific points, kind of pillars for the indoor mapping, as well as tags that could be placed around. Okay. What's this? Yes. That's the goal. So why we do this? Artificial intelligence and machine learning basically are enabling PIX4D to go to the future. Future is automation. And that's why we can reduce the time of the people directly on site, directly in front of the computer doing the mapping and the digitization. We reduce, the automate repetitive tasks, and we can achieve, thanks to the human beings, to their brain, also achieve more precision. The assisted vectorization and the actionable measurement extractions are kind of holy grails that have been always thought, and we finally can produce them. So that's our goal. How to go there? Then it's the next future, and that's why we are investing a lot in research and development, and partnering with companies that can really help us to achieve this goal. And that's it. I'm finished. And I really thank you for resisting up to the